This dataset contains data on births to women in the United States. Two variables of interest are the dependent variable, that is infant birth weight in ounces, which is represented by this name, and an explanatory variable, average number of cigarettes the mother smoked per day during pregnancy, which is represented by this name. The following simple regression was estimated using data on n equal to 1388 births. So this is our sample size. This is the equation of the line of best fit. In the first part of this question, they are asking us what is the predicted birth weight when CIGS, that is the average number of cigarettes smoked, is equal to 0. Well, in this case, all we have to do is in the equation of line of best fit, instead of cigarettes, we just have to substitute 0 over here. And if you substitute 0 over here, you will see that the predicted birth weight is just equal to the intercept term, that is 119.77 ounces. Okay. In the next part, they are asking us what about when CIGS is equal to 20. So for this part, all we have to do is in the equation of the line of best fit, instead of CIGS, we have to substitute 20. And in this case, the predicted birth weight will come out to be 109.49 ounces. So if we take a look at the difference is going to be minus 10.28 ounces. So when you're going from here to here, the predicted birth weight is going down by 10.28 ounces. That's why it's a negative number, because it's going down. Okay, which we can also see from here that cigarettes and birth weight have a negative association, because this number over here is a negative number, right? So this number over here, that is minus 0.514, is telling you what will happen to the predicted birth weight if CIGS increases by 1. So this is the slope. And if your CIGS increases by 20, then the number is going to be minus 10.28 ounces. Let's move to the next part. Does this simple regression necessarily capture a causal relationship between the child's birth weight and the mother's smoking habits? Explain. Well, the first thing that you have to understand over here is that whenever you want a causal relationship, you have to satisfy the zero conditional mean assumption. So let me explain it over here. Let's say that you have a regression equation like this. So this is a simple linear regression. Now, what does zero conditional mean assumption says? It says that expected value of u given x has to be equal to 0, which means that u and x are not related. So that means the variables in the error term u should not be related to your independent variable x. If you are able to make sure that this happens, then we can talk about causal relationship. However, if your u and x are related, then we cannot talk about causal relationship. Okay. And what is it that u is representing over here? U is representing the other factors or the other variables that affect y apart from x. Okay. So apart from x, whatever other factors affect y, all of those factors are there in u, right? So now let's see what is it going to be in our case. So in our case, we can write the model as birth weight is equal to beta 0 plus beta 1 6 plus error term. So the error term is u. Now we have to think of some variables in the error term. Okay. So start thinking of some variables that affects the infant birth weight apart from the number of cigarettes smoked by the mother. So some of the variables that I could think of are mother's education and awareness. Some more variables could be family income. It could also be age of the mother. And there are many more variables that could be there in the error term. I hope you get the idea. So when you're thinking about the variables that are there in the error term, you have to think of those variables that have an effect on your y variable, which in this case is the infant birth weight. Okay. Now I have written 3 variables over here. You can also write some other variables if you want to. If any of these 3 variables in the error term are related to CIGS, that is cigarettes, then we will have a problem, because in that case, the error term u will also establish a relationship with the independent variable, and that will violate the zero conditional mean assumption. And in this case, we can clearly see that mother's education and awareness will definitely be related to the number of cigarettes that the mother is going to smoke during pregnancy. Because we expect an educated and aware mother to smoke less cigarettes, in fact smoke no cigarettes during pregnancy. So how many cigarettes a mother is smoking is actually related to her education and awareness, right? So because this is happening, that means U and CIGS are also related. This violates the zero conditional mean assumption. So this violates zero conditional mean assumption. And because this assumption is getting violated, that means that this model will not be able to capture a causal relationship between the child's birth weight and the mother's smoking habits. So these OLS estimates that you see over here cannot be trusted. I hope this is clear. Let's move to part number 3. To predict a birth weight of 125 ounces, what would CIGS have to be? So to solve this, all we have to do is over here, we have to put 125, right? So the predicted birth weight is given 125. So now we have to solve for CIGS. So this is equal to 119.77 minus 0.514 cigarettes. That means 0.514 cigarettes is equal to 119.77 minus 125. This implies the number of cigarettes smoked per day is equal to 119.77 minus 125 divided by 0.514. And if you solve this, you will get that this is equal to minus 10.18. So this means that if you want the predicted birth weight to be 125 ounces, then the average number of cigarettes the mother smoked per day during pregnancy has to be a negative number, which is definitely not making any sense over here. And we also have to comment on this, right? So they are asking us what should be the number of cigarettes smoked if you want a predicted birth weight of 125 ounces. So the first thing that can come to your mind is that maybe a birth weight of 125 ounces is quite an unusual value. This can never happen. And that's why the number of cigarettes is turning out to be negative. So you may have started relating this to the case of extrapolation. However, let me give you a counter argument if you are thinking in the direction of extrapolation. And this is the data that I'm going to use to provide you a counter argument if you are thinking in the direction of extrapolation. So I have used the data set that is mentioned in the question. And as you can see, I've ran a regression over here of birth weight on the number of cigarettes smoked. If you can see over here, a birth weight of 125 is actually not an unusual value. So if you actually count that how many infants were born with a weight of greater than or equal to 125 ounces, then the number is equal to 540, which is around 40% of your sample data. So 40% of the infants in your data were actually born with a weight of either equal to 125 ounces or greater than 125 ounces. So the predicted weight that they gave us, that was not a very unusual value. So you cannot justify the negative value of cigarettes by giving an argument in the direction of extrapolation because you're not extrapolating over here. The birth weight of 125 or anything greater than that is quite possible. In fact, 40% of your sample data is actually satisfying that condition. The justification for the result that you are getting in question number 3 is that the model is not a very good fit. The model is a poor fit. The numbers, that means the OLS estimates that you have got, those cannot be trusted. In fact, if you remember the predicted birth weight that we had when the number of cigarettes smoked per day were 0 was equal to 119.77. So that was your intercept. You can see that in your data, almost 50% of your data, if you see over here, so 697 observations out of 1388. So almost 50% of the observations in your data had a value greater than the maximum value of birth weight that your model has predicted, right? What does this signify? This signifies that your model is not a good fit, right? I hope you're getting this argument over here. So, in the part number C, they also asked us to comment on this scenario that we have got, that if you want a predicted weight of 125, then how many cigarettes should the mother be smoking? And we got a negative value. So what is it that we are able to infer from there? The thing that we are able to infer is that the model is not a good model. 125 ounces is not an unusual value in your data set. In fact, almost 40% of your sample has a value greater than or equal to 125 ounces. And the numbers that you have got for the estimate of the intercept and the slope coefficient, they cannot be trusted as the zero conditional mean assumption is not satisfied over here. So overall, the conclusion is this model is not a very good model. Now let's move to the fourth part of this question. The proportion of women in the sample who do not smoke while pregnant is about 0.85. Does this help reconcile your findings from part number 3? Definitely. So think of it in this manner, that what is it that we were trying to achieve from this regression? We were trying to link the average number of cigarettes smoked to the child's birth weight. Now, in the sample data that you have collected, almost 85% of the women are non-smokers. They did not smoke during pregnancy. What does this mean? That 85% of the values of your variable CIGS is going to be 0, right? Because 85% of women are not smoking. So for them, the value of CIGS variable is 0. So that means that a lot of values of your CIGS variable is going to be equal to 0. And this means that this model cannot have a very good fit, because how will you link the number of cigarettes smoked to the birth weight of the infant if only 15% of your sample is smoking and the other 85% of the values of the variable CIGS is equal to 0? Okay, so overall this model will have a poor fit, and that is something that you can also see from here. So if you take a look at the R square of this model, the R square of this model is quite a low number. So that means only 2.27% of the variation in birth weight is explained by the variation in the average number of cigarettes smoked per day by the mother. So I hope this is clear. If you enjoyed this video, then do give it a thumbs up and share it with your friends.